think we go with the numbers below with the example as we draw out easier for you to remember the concepts. Okay, so I've got this point P and I've got a plane equation. Usually when you get a plane equation, can we first convert to scalar product form? So how you may view it is you can write in as x, y, z, and you dot the coefficients. I give you the logic behind it first. So if you write in the coefficients as a column vector, these two vectors dot out will give you this Cartesian equation, and we get equals to 16. So your equation is actually r dot 1, 2, 3 is 16. Hence, that vector 1, 2, 3 is actually forming your normal vector. With this normal vector, how do we find this thing called a foot of perpendicular from P to pi? Again, help me draw out the equation of a plane. The concept is completely different from foot of perpendicular last week to a line. We start with a point P at the top. We're going to draw a vertical down. This point that you hit at a 90 degrees, this point is called the foot, which we call it F. But we're going to deploy a new strategy. We're going to use this equation of the line that will be passing through this point P and also perpendicular to your plane. Let's form the equation of a line called L. Let me label as L. The idea here is this foot here is viewed as it is an intersection point. It is not about having the 90 degrees and we do dot product anymore. Let's view it as an intersection point. Hence, my first step will be, can we form such an equation? Let me label first. I want to get equation of L such that it will pass through P. So P is a position. What is the direction vector of my line? So if I want a vector parallel to a line or to this line, what will we be using? We will be using the normal vector. Normal vector is perpendicular to your plane. Okay, so I will say passes through P and it's parallel to N. Hence, your equation then look like R equals position. Let's go for point P. So I have 1, 2, minus 1 plus lambda. Direction vector will be your normal vector, which is your vector 1, 2, 3. And we say lambda is any real number. Okay, so to facilitate our next step, can we combine into one vector first? Number 2, I mentioned that it's an intersection point. We haven't learned that before. This is the first time. So we're going to intersect L with plane. How do we intersect a line equation with a plane equation? We will view it as it's going to be simultaneous equation, whereby you take the R from the line, you are going to substitute into the R of the plane. It's a substitution from one R to another R. Think of it like simultaneous. So we substitute that in, which means on the left, I sub in this equation of the vector. Put it into the plane's R position. Expand out the dot product. Once you found the lambda, the idea is to put back directly to R. Because what is R again? R is actually OR, representing any point on the plane. Sorry, any point on the line in this case. So if R is any point on the line, we have found that my foot will have that lambda is 1. So last step is to put it back into the first equation, and we will write indirectly as its OF. Sub in the lambda to be 1 to the very first equation. Okay, hence, this is that foot of perpendicular. The main idea you should remember is it's about this line and plane intersecting. A foot from point to plane is about intersections, not about the 90 degrees. Okay, there are more